So these are our group members. Let me introduce you to Howard Gardner's multiple intelligence theory. In the 1970s, Gardner, a psychologist at Harvard, was researching IQ tests. He found them too narrow because they focused only on linguistic and logical mathematical skills. So, in 1983, he wrote Frames of Mind, the Theory of Multiple Intelligences. In this book, Gardner proposed that intelligence is not limited to just one area, but includes a broader range of cognitive abilities. This idea shifted how we understand human potential, recognizing strengths in many different domains. Next. So Gardner identified 9 types of intelligences. The first 7 were introduced in 1983: linguistic, logical mathematical, kinesthetic, spatial, interpersonal, and intrapersonal. Later in 1999, he added naturalistic and existential intelligence. This theory highlights 2 key points. First, it helps us recognize individual strengths beyond traditional academics. Second, it encourages educators and learners to use more personalized and diverse approaches to teaching and learning. Next. Howard Gardner supported his theory with case studies from brain research and interviews. One example is a young autistic boy who struggled with language but could play complex musical pieces exceptionally well. This showed musical intelligence as an independent ability. Another case involved a stroke patient with aphasia who lost the ability to speak but could still solve puzzles and draw beautifully. This highlighted visual spatial intelligence. These cases prove that intelligence extends beyond traditional measures like language and math. In the 1980s and 1990s, Key School in Indianapolis applied Gardner's theory of multiple intelligences in real classrooms. Teachers used various methods, like puzzles in math, to match students' different learning styles. As a result, students showed higher engagement and participation, with their abilities becoming more visible across multiple domains.
Hi everyone, my name is Atika and I will be presenting about linguistic intelligence. Let's begin with the definition. Linguistic intelligence means having a strong ability to use language well. This includes speaking, reading, writing, and even using sign language. People with this intelligence are usually very comfortable expressing themselves with words. Next. Next. Next, I will share the key characteristic of linguistic intelligence. First, verbal expression. This characteristic can explain their thoughts clearly when speaking or writing. Second, reading and writing skills, which is they understand text quickly and write in an organized way. Third, vocabulary mastery. They know many words and use them accurately. Next. Fourth, storytelling ability. They tell engaging stories with vivid details. In addition, persuasive ability also the one of the characteristic for this linguistic intelligence. They can convince others using strong argument. And lastly, memory for language. They remember facts, names, and details easily through words. Next. Next. Now let's look at some real-life examples. People with strong linguistic intelligence often become authors, poets, journalists, public speakers, politicians, translators, speech therapists, educators, professors, lawyers, or judges. As you can see, this is how they use it in daily life. Authors and journalists write to share stories or deliver news. Speech therapists use clear communication to help clients improve speaking. Public speakers and politicians inspire or persuade others with their words. Lawyers and judges use precise language when arguing or interpreting the law. And finally, educators and professors explain complex topics in a simple and clear way for students to understand.
Hi, good evening, everyone. Tonight, let's explore linguistic intelligence, our ability to use language to express ourselves and connect with others. Our brains are wired for language, and there are three key areas involved. First, broadcast area help us to speak. Second, Wernicke's area help us to understand the language. And third, arcuate fasciculus connect in the two, allowing smooth communication between speaking and understanding. Now, let's look at some amazing people who've shown incredible linguistic intelligence. First, Maya Angelou, a brilliant poet and writer, though she faced trauma and stopped speaking for years as a child. She later, she later used language to inspire millions. Her books and speeches speak of strength, identity, and hope. Next, Malala Yousafzai, a young education activist. She began writing at age 11 years old about life under the Taliban and later gave a powerful speeches like the one at the UN, advocating for girl education. And finally, next, Barack Obama, known for next and finally Barack Obama, known for his powerful speeches and books. He uses language with rhythm, empathy, and clarity to inspire and unite people. So, how we can develop our own linguistic intelligence? Next, first, read and write regularly. It expands your vocabulary and ideas. Second, join discussion or debates. It will sharpen your thinking and communication. Third, learn a new language. It will help open up a new way of thinking. And fourth, play a word games and fun way. It was a fun way to grow up your vocabulary and language skill. In short, language is a powerful tool. By practicing and engaging it, we can all become a better communicator and maybe even help change the world. Thank you.
Now we will be talking about logical mathematical intelligence. Let's begin by defining what it means. When we talk about this concept, we are referring to a person's ability to think logically and solve problems effectively. These involve identifying and analyzing problems in a logical way, recognizing patterns in numbers, and approaching challenges using scientific investigation. In other words, it's about using reasoning and evidence-based thinking to solve problems rather than relying on guesswork. To illustrate this, think of historical figures like Albert Einstein, who is shown here. Einstein was known for his logical reasoning, mathematical skills, and scientific approach to uncovering the mysteries of the universe. Now that we have defined the concept, let's take a closer look at some of its key characteristics. First, numerical proficiency. This refers to the ability to work confidently with numbers. People with this trait are skilled at analyzing mathematical concepts and interpreting data. They feel comfortable when working with statistics and solving numerical problems, whether it's in a lab, a business setting, or daily life. Second, scientific and analytical thinking.
This is about approaching problems like a scientist. These individuals know how to design experiments and test their ideas. They don't just guess, they use evidence and data to draw conclusions. Hypothesis testings and evidence-based reasoning are second nature to them. Third, systematic organization. This trait describes someone who values structure and clarity. They approach problems in an organized, logical way, and they are skilled at managing and making sense of complex data efficiently. Next. Number 4 is logical reasoning. This means referring to handle complex information through a step-by-step logical process. Rather than jumping to conclusions, individuals with this trait work through problems systematically, making sure each step follows from the last. Next, we have problem-solving skills. People who possess this trait are drawn to challenges that require both creativity and analysis. They enjoy tackling conceptual puzzles, coming up with innovation solutions, and applying critical thinking to solve problems in new and interesting ways. And finally, pattern and relationship recognition. This refers to the ability to spot patterns and connections in data. People strong in this area can identify relationships between complex elements that others might miss. This skill is especially valuable when analyzing trends or solving multi-layered problems. Next. Now let's look at how logical mathematical intelligence connects to the brain. First, the left prefrontal cortex. This part of the brain is in charge of logical thinking, decision making, and working memory, all essential for analyzing problems clearly. Next, the intraparietal sulcus or IPS. This area plays a key role in mathematical tasks like arithmetic, counting, and estimation. And finally, the dorsolateral prefrontal cortex or DLPFC. It helps us solve problems step by step and stay focused during complex tasks.
Now we take a look at real-life application. First, we have mathematician. They analyze data, create models, and proven theories. As we can see, and take an example, is Albert Einstein himself. Secondly, computer programmer, software developer. They write and debug code, design algorithm, solve logic-based problem. Thirdly is engineer. They apply mathematical and scientific principles to solve real-world problems. Lastly, the data analyst. They use the statistic machine to use they use the statistic, machine learning, and data visualization to extract insight from data. Next is physicists and chemists. They conduct experiment and develop theories and use math to explain natural phenomena. Next, we have accountant and auditor. They manage financial record, analyze budget, and ensure accuracy through numerical analysis. Lastly, actuary. They use mathematics in statistics and financial theory to assess risks in insurance and finance. We can take a look on our case study. First is Albert Einstein. He a theoretical physicist. Albert Einstein is studied in Swiss Federal Polytechnic in Zurich. He won a Nobel Prize in Physics 1921 due to his success in photoelectric effect. Second, he's a logical mathematical intelligence proof. He introduced the concept of relativity and gravity. Einstein also teach physically law using precision mathematics, including the tensor calculus. Lastly, application of intelligence. Einstein transformed modern physics by integrating experimental methods. Second case study is Mark Zuckerberg. He is a computer programmer. Mark Zuckerberg is a programmer and entrepreneur. He co-founded Facebook in 2004 as Harvard University student, and now he currently CEO of Meta Platform. He is he is a logical mathematical intelligent proof. He CEO founded Facebook by himself, building global scale social media required extraordinary talent and skill in programming, algorithmic, and system thinking. Lastly, he used application of intelligence by applying data-driven decision-making and algorithm that allows synchronization of social media across all platforms. Here's some methods to develop logical mathematical intelligence. First, engage in mathematical problems involving sequence and pattern, for example, Sudoku and riddles. Secondly, practice solving strategy games regularly, like chess and Rubik Cube. Third, nurture interest in coding and programming to enhance abstract reasoning. For example, we can use Python. And the last list, use scientific method to perform scientific experiment.
Good evening, everyone. Now I'm going to talk about the special intelligence. The definition is defines as having greater ability in conceptual manipulating objects, shapes, and structures in mind. They are able to mentally visualize objects in three dimensions. Next, these are the key characteristics. 1. Strong visual imagination. Someone who can clearly imagine objects with accuracy, including its spatial orientation. Second, 3D thinking and mental rotation. Possess the ability to mentally reposition objects from multiple directions. 3. Good sense of direction. Has effective and proficient navigational skills. Accurately read maps and interpret charts. Next, 4. Artistic and design skills. Strong innate artistic ability, able to articulate ideas through visual media platforms such as drawing and painting. 5. Understanding spatial relationship. Naturally skilled in perceiving how different parts and shapes can be connected, then can form in the final configuration mentally. 6. Pattern recognition and visual data. Can quickly spot and interpret complex pattern and symmetry. Next. Next. Okay. These are the brain that connect to autonomy correlation. 1. Cartable lobe. Brain area possible responsible to process sensory inputs from multiple senses and proceed its spatial configuration. Second, occipital lobe. Brain area responsible in processing visual images and recognizing shapes and patterns. Lastly is hippocampus, brain area for navigation skills and location memory. Next.
Good evening, everyone. Today we explore the real-life application. We will see how architect plan structure, artist create that, engineer design system, and graphic designer craft visual layout. Next. Furthermore, we examine how surgeons perform precise movement with human body awareness and how pilots and sailors navigate complex environment using spatial intelligence. This presentation will showcase the critical roles these abilities play in diverse fields, from precision and innovation to navigation and creation. Moving on to our first case study, we have Pablo Picasso, a truly iconic Spanish painter and sculptor, and one of the most influential artists of the 20th century. Picasso was incredibly prolific, producing over 20,000 artworks, including not just painting, but also ceramic, print, and sculptures. His genius lies in his remarkable application of intelligence, particularly its visual and spatial understanding. He was a co-founder of the Cubist movement, which aimed to modernize visual arts by presenting artwork in the groundbreaking 3D forms. This approach integrated the mental manipulation of objects and a deep mastery of visual composition. He also introduced other significant artist styles like surrealism. Next, our case study, we have Walter Christaller, a renowned German geographer. Christaller is the best known of introducing his central place theory in 1933. This groundbreaking theory helped us understand the geographical distribution of settlements like cities, towns, and villages, based on factors such as population, size, and transport physics principle. You can see a visual representation of this hexagonal pattern in the diagram on the slide. His work demonstrates a powerful application of intelligence in the field of geography. Christella used his ability for visual thinking and a deep understanding of geographic patterns to create these real-world models of how cities and services are organized across landscape. It's a prime example on how spatial and analytical intelligence can be applied to understand and predict human settlement patterns. Okay. Let's look at some practical methods we can all use to develop and enhance this valuable skill. Firstly, engage in spatial games. Simple yet effective activity like jigsaw puzzle. Secondly, learn visual arts. By engaging with painting, drawing, sculpting, you naturally develop a better understanding of depth, perspective, and how objects relate to each other in this space. Thirdly, practice reading GPS and map manually. Instead of relying solely on automatic voice instruction, try to interpret maps yourself. And finally, engage in the video games with subtle elements. Games like Minecraft, where you build and navigate 3D worlds, or Portal, it challenges your perception of space and physics. Thank you.
So, in summary, Howard Gardner's theory of multiple intelligences allow for broader comprehensions of intelligences, encouraging individuals to value their own unique talents and abilities. By recognizing our own intellectual capabilities, we can personalize our learning methods to further maximize our future potential success. That's all from us. Thank you, everyone. Bye-bye.